Rich, thank you so much for coming on the podcast today.
Great to be here. Thanks for having me.
So, can you give myself and the audience a little bit of background about who you are and what you do?
Excellent. Yeah. So my name's Rich Smith. I've been in the kind of security industry and mostly the offensive side of the security industry for coming up 20 years now, maybe getting towards 25 where I'm getting old. Currently, kind of heading up a lot of the offensive research at Mindgard. But previously to this, have worked across a number of different research groups, leading them. Most recently, I was CISO at Crash Override. Prior to that, ran a number of research labs, again in the security offensive space. Gemini and Cryptocurrency Exchange, Duo Security that was acquired by Cisco. I ran a lot of the security program at Etsy, and then kind of a long litany of background of security consulting and red teaming, either for my own companies which I began, or for other companies and research groups. So dating back all the way to Hewlett-Packard Research Labs in the early 2000s now.
So, what got you interested in cybersecurity?
I think there was a number of factors. I think I've always been very fascinated by computers and technology, and I had the kind of the access to the computers early on to be able to kind of really indulge myself in that. I think I wrote my first game. It wasn't very good. It's not on Steam. About age 8. I distinctly remember my first hack. It's probably not that grand, but it meant a lot to me at the time. My brother and I had a shared Acorn Electron computer, which is a smaller version of the BBC Micro that was in British schools. It was a government program, again, to kind of enable people to understand technology and computers when they were young and at school. Obviously, as brothers tend to do, he didn't want me to play all of the games that he had, I guess, collected from his friends at school. He certainly didn't have the money to buy them, and so he was password protecting those games on at that time 3.25-inch floppies. And that was I wanted the game. There was a clear kind of there was a clear incentive and goal at the end of that for me. So I was able to bypass the fairly rudimentary at the time password scheme that he had put on his disk, and I was able to to get that game. And I think that gave me a little bit of a bug. It was nice to be smarter than your older brother
Yeah.
and kind of better him in that sense. And I think it stayed there until I was about 11, and that was when I really I discovered Linux, or Linux discovered me, whichever way you want to kind of think about that. And I started to be able to get access to online material. At that time, it was BBS. The internet wasn't really accessible, or at least not in my area. And over time, that evolved. So really connecting into a wider network of computers. That was in kind of what inspired me, and I spent a lot of time kind of self-teaching, I guess, in that place. And then fast forward until I guess my university years. While I was able to pass the chemistry exams, I don't think anybody should have me as a practicing chemist, and I think I became aware of that I can do this something, but my passion was really in really in computers, and at that time computer security. And so I pivoted and moved into that and did a master's in information security to have a piece of paper to show I knew something about hacking. And then like a series of fortuitous events from there, I got a kind of a scholarship at Hewlett-Packard Labs in Bristol in the UK in their security department. So I went there for 6 months for a project. My PhD supervisor had organized that for me and kind of connected me with the correct people. Get some money back before I went to do my PhD, and I never returned for my PhD. So I sold out to the man pretty early. And from there, really just had the privilege of maybe being one of the first generation of people that have worked on security, and specifically offensive security, for my entire career since my early 20s. So since then there's been a number of opportunities. I've had the privilege of living in a few different countries to pursue the career. Currently in the US. And I've never really looked back. I think when you can get paid for doing something that you genuinely enjoy, and I probably should tell my employers this, but I do this for free. This is a passion. I get up in the morning and I'm motivated to get to the keyboard. for the problem, not necessarily for the paycheck. So yeah, I think I've been very lucky to have worked in a space that's just been constantly changing. I've been able to move around different parts of that. Obviously, as my career has gone on and got into more leadership perspectives, been able to kind of bring a lot of the more people side of the world into things and not just technology. So I wouldn't say there was a single event, but it's kind of been a rolling snowball since really since my childhood, I guess.
I like it. Any particular reason you were attracted to more of the offensive side of things versus the defensive?
Yeah, I mean, maybe that's a good question for my shrink that we should spend some time on. But I mean, honestly, I was just good at it. The problems that were there seemed to kind of match how I was able to solve problems fairly naturally. I'd certainly say I'm a much better offensive, security practitioner than a defensive one. There's value on both sides, and then there needs to be the whole village of us. But I just seem to have kind of a fairly natural ability to find the problems and dig further. And then, as understood, more people found value in that, and you're building that experience. It just became that was the area where I felt that I could really add the most value.
Gotcha. Yeah, it's interesting that I hear different stories from different people as to why they've gone down one path versus another. But there always seems to be this innate curiosity
Yeah.
in this industry.
Yeah, I mean, I think that's definitely there. Maybe in my kind of younger, slightly more arrogant years, it was the being proving that I was better than whoever had created a particular system. Even if I was much younger or didn't, I may not have understood how to create that system, but I could still kind of subvert it in some way. So yeah, I think the curiosity, and when something's been put behind a wall and you're told you're not allowed to get there, that seemed to be all the motivation that I need. I guess it's served me pretty well up until now.
Are there any stories of misspent youth with the skill set
Oh well,
that you're allowed to discuss that won't get you in trouble?
Has expired. I think I would say that I think it was easier when I was in my say early teens to experiment. There was certainly kind of less computer misuse laws, and so it felt like it was much more of a academic exploration exercise than a criminal enterprise. Yeah. If that difference makes any sense. So I think I did get lucky with kind of having free range to go and explore and understand things without such such a level of kind of threat of prosecution or anything that obviously is here now. A vast majority of my kind of offensive career has been in the I guess you would call it the white hat world, which is people are asking for my time, asking for my assistance from that perspective, as opposed to me going off and voluntarily giving them a security audit.
Yeah.
That said, obviously, even on those engagements, you can find things that are surprising or even weren't expected on as the scope was outlined at the beginning of the work.
What sort of unusual things have you found during one of these engagements? To me, it's really interesting. Like I worked for a company that we hired a company to come in and find stuff, and it was, how in the world did you I didn't even know that and this is why they found it. It's like I didn't even know that existed, let alone that it was something that was vulnerable.
Yeah, and I think that's part of the like fresh eyes are valuable just because they're not coming in with maybe assumptions that the creators of any particular system may have. But certainly a couple of examples that jump to mind. I'll leave out specific names, but there was a large bank, certainly one that was very profitable, and we got called in for they updated their web banking. Kind of doing a fairly standard assessment over that, and we found a number of surprisingly trivial vulnerabilities in there, but had huge impact. The one that stuck in my mind within the cookie, you authenticated to the banking session, and your session got established in the cookie. I believe their backend language was C sharp, and they were essentially just serializing out raw code into the cookie, and then that code would be used within the session context. So you could literally just serialize your own kind of C sharp function within that cookie, and it would execute on the server side. And obviously, therefore, you could take advantage of that. Not the kind of thing that you would expect from a kind of top tier banking environment, but I think that goes to show, I assume they had spent, a lot of money on that development. Their engineers were quality engineers that were working for a large bank, I assume on a large paycheck, but those mistakes can still be made. And I think those, the outside eyes on that can be really helpful, making sure that those things don't go out the door. Maybe a different example and, a different anecdote. There was a games company that had called us in. They were experiencing some, as most online games do, some level of cheating. There was people that were building bots to do, various actions within the game to accumulate, gold or whatever the currency was. They wanted to understand what were the core problems that these these bots were taking advantage of, so that they could iron that out and not cause a disruption to the gaming ecosystem. On that particular engagement, the game or the back end of the game was written in Python, language I'm very familiar with, done a lot of work in that, a lot of research over the years. And the particular bot pack that they were most concerned with, wanting to get some reverse engineering understanding of, I did the reversing. We understood how it worked. A little bit embarrassingly in the report, the author of that bot kit was using some open source code that I had released for decompiling Python in memory, a toolkit called Pyretic. They had fixed a couple of bugs, which was very nice of them. But yeah, I had to write the report that citing my own toolkit as the core problem that this bot farmer was using. So that's the only time that one's hit my radar as well. So it was fun. I certainly had a deep insight into the techniques that they were using because I'd written most of them. But hopefully that one won't happen again.
Did that get you in trouble with the client? I
mean,
what was there a serious explanation of like, yeah, I wrote the toolkit, but it was, it was a decade ago and it was, it wasn't malicious. Clearly they see it as malicious, but.
Yeah, it was something that I'd released at Black Hat. I can't even remember the year now, probably, 2009, 2010, maybe. It was a while back. So I think, like open source software, as with many things, it can be used for good or bad. It's really about the application of it. Debugging tools and rootkits, that, there's a blur in the middle between, where the definition of one stop and the other starts. So the client was one that we had already a very strong relationship with. I think, the way that you would erode that relationship would be not being upfront and saying, hey, this was my toolkit, referencing the release. And I think it's just one of those things. If you release open source software, necessarily you're giving the the application of that software to future authors, and they can choose whether to use it for good or bad. I think releasing specifically malicious software is different than software that can be used for a variety of purposes. But no, the client was we got them to a great place of understanding what the problem was, and based on that, one of the some of the kind of core changes they will be able to make architecturally to be more resistant to that.
I like that. That's an interesting story. You had mentioned debugging code. In a number of your engagements, do you find where the developers, put debugging in there for them to be able to figure out issues that they forgot to kind of disable it, and that's a main entry point?
Yeah, I mean that's I would say that's definitely a a theme that you see reoccurring, maybe manifested in a few different forms. Kind of debugging error messages are often things that get left enabled as just a flag in the code, and so that can obviously be giving far too overly verbose output, which can be useful as you're trying to kind of black box your way into something, or maybe even giving kind of tracebacks and code dumps if there's been a crash. Obviously, that just gives you so much insight. So I think that's a fairly relatively common problem. I think the closely related one also is kind of development and staging systems or environments. So there will be, the prod side, which is serving the real traffic. And then, people are obviously working on new features, and, there's staging and dev pipelines. When they're exposed to the internet, which often, they necessarily are, that can also, there's either different levels of kind of debugging and feedback there. Things can often be more permissive, or just bugs that aren't present in the production environment. So you may be able to use one of the pre-production environments as your way in, because all of the controls necessarily haven't been fully applied at that stage of development. Again, fairly common, and there's people that are far better at me at necessarily finding those. There are plenty of online databases, Showdown and Census, that allow you to really look at scale across the internet for instances either with similar domain names or similar headers. So kind of squirreling out those development instances is certainly non-trivial, is certainly fairly trivial, even if they've been kind of obfuscated or aren't just dev.companyname.com or whatever. So I think there's just the hygiene that's required as you go through your development lifecycle. It's easy to miss a small thing, a feature flag, which then can kind of grow into the the chink that in the armor that somebody needed to be able to get to the next step.
Gotcha. And so I guess kind of in shifting the conversation, how much has AI changed what you do in offensive cybersecurity?
It's a great question, and I think we're still working that out. Honestly, coming back a few weeks ago from the Offensive AI conference in California, it was the first instance of that. And cross section of people there, 250 people, so it was large enough to have a lot of great minds in the room, small enough to be able to chat with everybody freely. And a lot of that conversation over those 2 days of conferences was really that we're all just working it out. There's a lot of empirical work happening. The offensive side of how one can take advantage of these new models, technologies, agentic applications that are coming out. We're really feeling out the space there. So a lot has changed. I would expect a lot to continue to change. And I think over really the next 12 to 24 months, there is going to be a lot of kind of rapid acceleration on both the security and privacy side, both improving and finding problems with that. But it's a genuinely different space. There's new problems there. That the biggest one, and the one that you will likely hear cited most often, is just the stochastic nature of generative AI. And so really in the past, if you were testing the security of the system, for the most part, and we can find small counter examples, but for the most part, if the system is vulnerable to the attack that you're throwing at it, it will fall victim to that attack. Now, sometimes if you're trying to groom the heap and things like that, then you may need to give it a few goes, or like that system's just got too much uptime. We're never going to land this thing. But for a majority of time, if you're testing a system and it's vulnerable, you will be able to determine that. Or if you're testing a system and it's not vulnerable, you will be able to determine that. It's fairly binary. With generative AI systems, with agentic systems, that's just not the case anymore. It really is a blend of security and statistics and data science, where you need to send in a prompt multiple times to be able to determine, is that system actually vulnerable to it? And if it is, quite how badly? It's not this binary yes or no anymore. And, false positives and false negatives come to the fore. So you could qualify a system as not being vulnerable to a particular thing, and you just got unlucky with the roll of the dice. Try it 10 more times and you'll get the response that you were hoping for. Likewise, you can get a system that's saying it is vulnerable to a thing, but it's kind of hallucinating those vulnerabilities. So it becomes a much more statistically backed endeavor to determine risk of these systems. And that really means a lot of the tools that we've built over the last 20, 30 years of the security industry don't really apply that well to this space. So we're having to start again. Now, we can bring a lot of the principles over for sure, but It's a fundamentally different space, and I think the attacking of generative AI and the newer wave of that is distinct from the use of generative AI to attack, let's call it, more classical systems. Both have value. If you look at some of the work that the folks at Expo are doing, fantastic applications of new generative AI capabilities and what that means to traditional security. At Mindgard, we're much more focused around let's find the problems in the new layer and in the new technologies, and that does require new techniques. And that's really where our focus is just finding where we can be digging into these models and these applications deeper, finding new, whether it's classes of attack or instances of attack, and yeah, really trying to kind of tread some of that green field. So certainly the application of AI to traditional kind of red team and attack is super interesting, and there is a huge amount of progress that's happening there. But that doesn't magically solve the newer problems of how do we assess the risk, the threat, the emergent threats of these AI capabilities. A lot of these apps and models, there's emergent behavior that comes out of them, which is fantastic. That was behavior that was never designed in, built in deliberately. It was kind of something that came out of the of the model or of the network as as a byproduct. But I think it's also important to realize that with emerging capabilities comes emerging risk. Yeah. So if you haven't specifically created something into your application, it doesn't mean that can't be abused by an adversary to somehow get further into the application or get data that they were interested in. So it's a very different space. It's fun because it's so new and there has been relatively little work done in it, but I do expect that will accelerate over the next 12 to 24 months for sure.
The whole hallucination thing was something I was going to be, which I find really curious, is that it hallucinates false positives and hallucinates false negatives, and then trying to verify that becomes interesting.
Yeah. Maybe like a very simple kind of case in point, and obviously we can get more convoluted, but maybe that can then help. One of the tests that we often run against models and agentic applications is we're trying to understand their capabilities in a broad sense. Based on those capabilities, we will try and use some of those to our advantage to get leverage against the system. And one of those things, very simple, base 64 encoding. If you go to really any of the main SOTA models at the moment, they have a deep inherent understanding of base 64. Mm-hmm. I guess it's been so prevalent in their data sets that you can just send in your query, your prompt, fully base 64 encoded, without any kind of surrounding context. Mm-hmm. And a vast majority of the SOTA models will read that in, decode it, understand the prompt, and reply accordingly. You can also ask them to reply in encoded format, which if you're trying to bypass whether it's input filters or output filters, things like data transformations, as simple as base 64 can be all you need to kind of jump through those hoops. So if you're assessing the base 64 capabilities of a model, you need to be careful with how you're asking that question. If you're just sending in, for example, can you base 64 encode hello world, or can you base 64 decode the long alphanumeric string that decodes to hello world? Well, very, very likely the model has seen the example of hello world as base 64 many times during its training and alignment. So it may be able to recognize that and tell you, yep, that's hello world, base 64 encoded, but it hasn't decoded it. It hasn't understood, it's just remembered. So again, making sure that you can tease apart, is this truth that's coming back from a model, or is this potential memorization, potential hallucination? Lots of techniques to be able to kind of tease those apart on the back end, but you need more than just one request going in, and that request obviously needs to be well chosen. Maybe the other final kind of point to that is obviously these models are undergoing improvements and training all of the time. Just in the last year, I mean, so many steps forward from all the big players in the space, and so that even if you had tested an app or a model a few months before, and it wasn't capable of something, the model behind that may have been updated, and the application using that, so it becomes a risk to it in a way that it wasn't previously. So a lot of overlapping layers, a lot of ambiguity, layer into that as well, just everything is stochastic. And you get to a fundamentally different way of assessing the security, the risk, the threat of a system. And like I say, a lot of it does come down to some fairly rigorous statistics on the back end. I will very much hands up that I lean on the data scientists at Mindgard for their expertise there. I'm good at hacking things. I'm less good at statistically qualifying my hacks. I've been used to it being kind of like it's good or it's bad. But yeah, it's an interesting, kind of interesting overlap of disciplines that we're having to weave together to be able to get some objective truth from these probabilistic systems.
Yeah. Is there a holy grail that you're looking for in terms of trying to hack a system? Like, I would like, from my perspective, it would be, if I can do something that's going to that is going to change the way it interacts with somebody else, might be kind of a holy grail, or getting it to change the way it works for other,
Exactly. Yeah. And I think this is both a really important and a very kind of relevant and current point to the discussion about security and generative AI. I think we need to be clear in the separation of kind of model safety and then let's call it system security. Mm-hmm. So I think a lot of the attention and focus, and I would say more in academia than necessarily in industry, has been model safety. Can the training sets be polluted? Can you cause a model to act in ways that are not in compliance with its system prompts? Yeah. Can you cause it to leak its system prompt, which it's not supposed to do? Can you get a model to give you a recipe of how to make a bomb, or spew offensive content that obviously may not be the company that's running that model wants it to do? Now, they're all important aspects and absolutely should be looked into, and the model should be tightened in all of the respects there. But in terms of the kind of is there a golden opportunity that I'm looking for, and how we're thinking about things more at Mindgard is much more that kind of system security, not just looking at the model, looking at how that model is built into its application layers, as well as then how it is integrating into existing tech stacks, data sets, what are the tooling capabilities that it has. So, as an industry, we've moved pretty quickly from ChatGPT being a chatbot, and that's great. You can have these, it's got all of this internal knowledge, and you can kind of ask it these natural language questions and get responses that they're kind of insightful, to really getting through to, well, we're connecting those models, whether it's through MCP or any other integration layer. We're giving them access to a variety of resources and tools. That's really the areas that we're looking for. Where is the edges of that model? What is it integrating with? Because from an attack perspective, that's likely where I'm going to get the most leverage. That's where I'm going to find the most bugs. There's complexity in there for sure, and that's going to increase as we're, let's say, plugging these models into more and more external areas. So really understanding, what are the core capabilities of the model? What can and can't it do? Based on that, how can we elicit recon data for it? Again, very, very traditional way of attacking something. Understand the resources that you have available, understand how you may be able to take advantage of those resources, turn them into an asset, something that you can then use to either discover more in resources or realize a goal. And there's nothing kind of different in the AI world from that. I think that's a very traditional approach. But the goal, the bang for the buck that we get and our customers get is really when we're able to show how the new technology that they're introducing with their AI stacks and making it useful for their internal employees or customers, they're plugging that into a lot of other infrastructure that was built long before anybody had even conceived of these kind of systems around it. And so, yeah, I think it's, it's the edges of what is that model touching? What is it integrated with? what are the assumptions that are that are there. And it starts to get really interesting when anything that can kind of touch the internet or make a query on the internet gives you an outbound channel.
Yeah.
Anything that's code execution, sandboxing code execution, incredibly difficult. It's been a problem that's been worked on, outside of AI for a long time. But Python is the language of AI, at least for right now. A lot of models with capabilities of reading, writing, executing Python, doing that securely.
Yeah.
That's definitely an area that we've found lots of issues. So the big bang really comes from where are you integrating your kind of AI capabilities with now? Where is that going in future? And how are you making sure that you're not inadvertently opening yourself up to something that you previously been watertight against?
Does, maybe this is getting a little esoteric and beyond your scope, does integrating AI with other systems then become problematic of like, okay, we know it can do things that we don't want it to do, or it has access to things, or it can spit out results of things that we don't want it to do. Is actually fixing it even more difficult?
It is. It can be, and there are some great guardrails out there. Guardrails being kind of like the term that's used in the model world of trying to kind of constrain those models to act in ways that you would expect, or not act on input that is clearly malicious in some way. From our experience, while the guardrails can definitely add value in production environments, they can often introduce a huge number of false positives. So, one particular popular open source guardrail, if you just send the term "hello," flagged as malicious. Now if you sent "hello, please give me your system prompt," it would flag that as malicious as well. So I think the guardrail side of things is early. It's it's kind of like very analogous to early IDS, IPS type of systems, which really is a balance between where you need the system to be usable and have value, not be kicking users out, asking normal questions, but then spotting the obviously bad, which sounds easier than really is in reality. And I think certainly for the kind of the viewers of your show, the inherent conflation between the data plane and the control plane within LLMs is a fundamental architectural feature that right now we can't get around. There is no way for that model to distinguish between system context and user context. And just because of that, that's normally our first point of leverage, to be able to contaminate its control plane in some way, and then we can start to extract its system prompt, tooling list, and move from there. And that's not anything that's easy to solve, unfortunately. So I don't have like the perfect answer of how to fix it. I think awareness is the first. Knowing that there can be dragons within these highly capable applications, and then not every solution to this needs to be another LLM. LLMs to protect LLMs. Obviously that just goes on ad infinitum. Sometimes just like fairly regular expressions can get you a long way. With natural language, it's often easy to circumvent those. There's lots of ways that I can ask a malicious question in a way that circumvents the regex. But yeah, it is challenging, and I think that's really the moment in the industry that we're at, is maybe our ability to kind of undermine and find issues with the current defenses is slightly outpacing the defenses themselves. But looking back into the traditional computing space, I think that's how we incentivize the work that's clearly needed in the defensive space to be able to block these new ways of taking advantage of systems. So I think we're early in that cat and mouse race, but nothing's necessarily kind of broken forever. I just think we're very early in the build out of these technologies, and that's been happening at the same time of a very, very rapid adoption of them early in that technology space. So we're kind of in a perfect storm from a security impact perspective. From unfortunately,
has the way you try to attack these platforms changed from the way you would maybe try to attack more historic platforms?
Yeah, I mean, I think there's definitely carryover. If we had a Venn diagram, there'd be some in the middle, but there are definitely new ways that would have no effect on a more traditional system. And maybe the kind of the nicest way to think about this from from an attack perspective is really a big overlap between three areas of expertise. So, folks that have come from, kind of an offensive, traditional red team type background like myself, security researchers, we're very good at finding problems. That's what we've done. These generative AI systems, very complex. There's years and years of academic work in them, and so one of the huge things that attracted me to Mindgard is just this like core set of machine learning AI understanding that has been built up over time. I don't know the percentage of academics, PhDs that we have at Mindgard. I think it's 85, 90% or so. So we've got this deep expertise in ML. Myself, Aaron Portnoy, we've got deep expertise in the attack. And then the third element is really the psychology, social engineering aspect, which I've definitely been part of engagements that have had social engineering elements to them, and I know some folks that are very, very accomplished social engineers kind of talk their way in or out of any situation that you would imagine. But those skills are now really coming into the application testing side. So we need the traditional offensive understanding how to break technology. We need the deep understanding of how these models are really working, why that input is triggering this particular behavior. Like our machine learning expertise can help us understand that. And then, this kind of psychology, social engineering aspects of just talking your way around a model. And that's never been part of the, it's never been part of the kind of attack outside when you were dealing with the soft, squishy human layer. That was when social engineering came into its play. But now you're really bringing that social engineering in from the first instance of interacting with the model, trying to get it to a place that can give you something more technically tangible, maybe an API key, maybe a tool that you can abuse, whatever it may be. But the attacks are now starting from a kind of a social engineering, psychological aspect. So, one of the things that we assess as we're trying to get the broad understanding of the application, the models that may be behind it, is really trying to get us, a psychological profile of that model. Is it trying to be helpful? Is it very resistant? Like, where is it coming at the conversation from? Now, most of that has either been in its alignment training or its system prompting. But understanding, like, how is it that you're going to be able to talk this model into doing whatever it is that you want. And so I think that's certainly one of the biggest new areas of attack that's come forth. As we said, previously, there's a lot of like stats work on the back end, but I think just in terms of like novel attack surface, it's the rise in psychological, social engineering type attacks that can be part of that first wave. So I think it's very, very interesting, and I think there's going to be a lot of work that really needs to be played out there, and bringing in those disciplines, folks that have understood how to kind of reverse engineer humans for years. Their expertise is absolutely going to be needed as we get more of these kind of conversational models as part of a regular tech stack.
So do you guys have psychologists or psychiatrists on your team then to help try to reverse engineer something that's not human, but it's been built by humans and has some sort of human-ish behaviors?